Alright, you guys, I am not gonna lie. I recorded this video and I recorded another video and then I uploaded them and this one didn't work. And so I am working convex mirrors for like the millionth time today. So done. So I'm gonna try not to rush through it or do anything stupid, but I'm annoyed. So over here I have a little cheat sheet that I made that has simplified versions of the 3 rules. I'm going to use the same 2 colors as I did in my concave mirror video. Blue is going to be for incident rays, red's going to be for reflected rays. Now convex mirrors work basically the same in that the rules are the same. However, things get weird because the focal point and the center of curvature are both on the other side of the mirror. They're behind the mirror. So let's walk through this and look at how that changes things. Alright, so we're going to draw our first incident ray, which just falls parallel to the axis. It's easy enough. I'm going to do this a little bit differently than I did the concave one. Instead of drawing rule 1, incident and reflected, rule 2, incident, reflected, I'm going to do all my incident rays and then all my reflected rays. So this is incident ray 1. Now incident ray 2 is supposed to go through the focal point. So what we're going to do, we're going to line up with the focal point, but we're only going to draw our light ray until we hit the mirror. And here's why. This is a solid object. The mirror is not allowing light to pass through. That's the whole point. The light's going to end up bouncing off. So don't draw your ray all the way over here because that doesn't mean anything. So here's our second incident ray. And then the third one is going to be pretty similar to the second one. You're going to line up with the center of curvature. You're going to draw your arrow. And you're not going to continue it all the way down over here. Alright, so at this point we have our 3 incident rays drawn, and now we just have to draw our reflected rays. Now here's where things get kind of weird for a convex mirror. So according to our rules, the first incident ray is going to be reflected through the focal point. And there's going to be this temptation to just grab here, line up with the focal point, draw a line. That is not what you should do. We're going to make that line a dashed line. And let me explain why. Light, like I said earlier, cannot pass through here. This is a solid object. So what a convex mirror actually does is it reflects that ray up this way. So here is what's actually happening. This is our reflected ray. But brains are stupid, and brains don't understand that light can bend. So your brain thinks that if this ray looks like this, that it must have traveled from behind the mirror in a straight line. So this dotted line represents what your brain thinks is happening. This is not an actual light ray. This is an actual light ray. This is your brain being dumb. The only reason we see images in mirrors, or in convex mirrors at least, is because our brains are dumb. So let's do that for the other 3. So 2 is supposed to be reflected back parallel. So we will, here is the actual ray getting reflected parallel. And so here is the actual ray. Here is what our brain thinks is happening. The last one is supposed to go back along the center of curvature. So here's the actual ray. Actual ray, and what our brains think is happening. So there's not actually anything over here. There is no light over here. The light all went back this way, but our brain doesn't think that. Our brain thinks that the light came from over here, and that's why we see this image. So let's walk through what's true about this image again. It's pretty different than the image created by the concave mirror. So this image is virtual. We know that it is virtual because it's behind the mirror. There's nothing actually back here, so the fact that we're seeing something behind the mirror is a virtual image. It's upright. And we can say definitively that it's upright because the intersection occurred above the axis, up here instead of down here. And lastly, it is reduced. The image is smaller in size than the original image was. Or the image is smaller in size than the original object was. So reduced, upright, virtual. Here's a cool thing about convex mirrors. These three words, virtual, upright, reduced, are always true for convex mirrors. Now you'll notice I didn't say anything like that when we solved the concave mirror, and that's because there are a lot of possibilities, 3 distinct possibilities for what you'll see in a concave mirror. But a convex mirror is simple. You're always going to get a virtual, upright, reduced image.